As a really wise man once said, learn the most by sharing your knowledge with others. So here we go. Whee! I lied a little bit in my talk title because using the workflow component for e-commerce is really about using state machines and about using events. Using these two things together makes for really good decoupled code. So this talk is really about writing good code. And we all want to do that, right? This talk assumes little knowledge from you. I'm going to teach you what a workflow component is. I'm going to teach you about events. And I'm going to teach you about state machines. How many people here have used Symfony before? A lot of you. But not all of you. I'm going to show you how to use the Symfony workflow component without any framework at all. So you don't need to know Symfony for this talk. This talk is open source. So what does that mean? It means that I want you to be active in this talk and think of things you want to ask. And I will have a demo in the middle of the talk. And if you have questions that I can show you in the middle of the demo, that's great. Because I give this talk for you, and you contributing to it is amazing. And if you still get nothing out of this talk, here's a picture of me with a dragon. I'm Michelle Sanver. I'm a color and a code addict. I've been programming since I was a kid, dressed in rainbow clothes, 9 years old. So that you don't spend the entire talk wondering about my accent. I'm born in Sweden. I lived in the Netherlands for 6 years. And then I moved to Switzerland. And I'm also half Danish. So basically it's European. And I work at this awesome company in Switzerland called Leap. Who has heard of Leap before? Only a few people, cool. So we do this thing where we don't have any management, so I can do anything I want to. Literally, but I'm still a developer because that's what I want to do. At Leap, my main task is to work for a huge, huge API. It's one of the biggest retailers of Switzerland. And this API is built in Symfony. And it's really, really fun. We've been working on this for over 5 years. We use a lot of technology, and it's millions of products. But if you've been working on an API for 5 years, something you learned 5 years ago is not going to be as cool today. So we got this opportunity from the same client to build a new API because they had this great idea. Let's do Uber, but for shopping. So what does that mean exactly? It means that we got to build a new API, and we got to build Uber, but for shopping. And when we got to build a new API, having been API developers for so long, we wanted to make it perfect. And we thought about all these things. Uber for shopping, what does this mean? It means you go to a website, you order all the things you want to order, you click checkout, then all the people in your postcode who have signed up for delivering the postcode, they get a notification that they can pick up your order. They press assign this order to me, and the order is assigned to them, they the groceries, and they deliver. Simplified Uber for shopping. Of course, in an API like this, we had some challenges involved. One of the things is keeping orders and prices up to date, because in a web shop, and especially when it comes to groceries, there's going to be discounts every Tuesday. And who maybe makes a cart on Monday, puts all the groceries in the cart, and then on Tuesday all the prices are up to date? Or, you know, all the kinds of things can happen, and you don't want anything to be out of date at any time at all. If you do, you get a lot of complaints, and you don't want complaints when it has to do with money. So we always have to double check and update prices. And obviously in an API, we want to make the consumers love us. And after all these years, I learned that there's really only 3 things that make consumers love you. It's having really good documentation, really good error messages so they know what happens when something goes wrong. And so they know it's their fault, so they don't have to contact us. That's great. And also that you're responsive and support. Next challenge is handling a cancellation of an order. It sounds pretty simple, but when you think about it, if someone has already pressed checkout, there's a credit card reservation, and maybe a lot of people got the push notification saying they can pick up the order, everything has to be smooth and they can no longer do that. And wherever it is in the cancellation, they should also be able to make a new order, since they can only have one at a time. With an API like this, with one of the biggest retailers of Switzerland, we thought it might become quite popular, and when they want to send push notifications to everyone who signed up for that postcode, we're going to have to deal with a lot and a lot and a lot of push notifications and SMS. It's pretty straightforward. So, many years ago, I heard about state machines from a friend of mine who, at that time, was really, really into quantum physics. And he kept talking about quantum physics and this amazing thing I never could grasp my head around. And then he got interested in state machines. If this guy who's really into quantum physics gets interested in state machines, it must be complicated, right? Luckily, it's not quantum physics. Let's break it down. So why did we want to use state machines in the first place? We knew we had to keep track of our orders. We had to know when an order was opened. We had to know when an order was confirmed, and what state the order is in at all times, so that we can do the correct things at all times. So that's important. We need to know what needs to be done. And a state machine is, you guessed it, something that keeps track of a state. So let's get into that. The classical example is a traffic light. You have 3 states, green, yellow, and red. So green goes to yellow, yellow goes to red, and red back to green. And then you have something that changes the state, like a timer. And how does a traffic light decide on that exactly? Maybe 1 second interval, so it transitions from one state to another in 1 second. And same for all 3. And then you have, so that if the timer is 0, it goes back to the same state to keep it green. And it keeps it green and it keeps it green. And same for red and yellow. Now we have 3 states again, green, yellow, and blue. But this time it's a workflow, because we transition from green to blue in transition 1, and then from green to yellow and blue in transition 2. In a state machine, you typically want 1 state, not multiple. And a workflow often goes from one to the other after something is done, while a state machine does something and changes states. Workflow is flowing, a state machine goes actively and changes state. So to turn this into a state machine, you add a 3rd transaction, so every transaction has only 1 state. And that's a state machine. The cool thing about programming is that we already think in states, and this is a pretty common concept for us as programmers. We always have to think what's going on when we want our code to be safe. We always have to think, okay, is this doing that? Is this doing that? For instance, is this value null? We already check state of that value. This is nothing new for us. So let's look at the order state machine. Our happy workflow, an order is created, items are updated, user sets delivery address and order, user checks out, pickers get notified, picker accepts order, picker goes shopping, picker delivers the order, and card gets charged. That's a happy workflow. We see that we have open, confirmed, assigned to picker, picked up, and delivered. That's the states. And of course, then later on, we realize it's not all happy, so we have two other states, cancelled and aborted. Cancelled is when support cancels an order, and aborted is when it times out and can't find a picker in a postcode. And when it times out, we might also cancel by system in some cases if an order has some difficulties where support did not cancel it. So that's all our states. If we don't then put lines between them, we see a graph. And it's becoming really beautiful, because a workflow is really just a graph. And if we label all the transitions, we here have a state machine. Now, in a state machine, one thing that many people forget is that it's very valid to go from the same state to the same state again. So, for instance, to update items, we want to keep the state in open, but once we check out, we no longer can update items. So, state machines make business logic very explicit. This is a state machine, and it's very easy to see what's going on in our application this way. That helps our documentation. Now, it's important to know that a workflow does not contain all logic. It helps you, and it helps you see where the flow is in your application. And that's very important. So let's look a little bit at the workflow component. You require it with Composer. And our workflow here, we have to define it in a configuration. In Symfony, we often use YAML. So here's how the configuration would look like, breaking it down. We have the name of the workflow, which is order. And we say that it's a state machine. And the marking store could be either multiple state or single state. We want it to be single state because it's a state machine. And also the argument state, that's the argument on a model. Typically, you want the model, if you're using Doctrine, to be a Doctrine entity, because that way you can change something in the entity, then do the transaction, and then afterwards flush. And that way, if the transaction fails, you never really save the entity in the database. It's pretty cool. But if you don't use Doctrine, I'll show you shortly how you can do that in a very simple application. So places is all the states, and transitions is, I guess, all the transitions. So you can go from one state to another, and then we have the model. So in the model, we thought, as people who had just been starting to use the workflow component as it came out, it would be a good idea to have all the states and define them as constants. That way we don't have typos in our application, because we have to use these names a lot. And what happened? No? So, I think my computer wanted to step ahead and go to the demo immediately, but here's the constants of all our states. And we do the same for transitions. And then we have here the private state property. And we define that it's open by default because an order always starts as open. I didn't like this one single bit. It sucked. I don't recommend you do this. Forget what you just learned. It's great to use constants, but if you do that in an entity, guess how many times we forgot to update the entity if we edited the states? A lot, and it causes bugs, and it's annoying. So, let's do a quick demo. I don't want to keep you too long before your lunch. Okay. So I made this very simple application, which here. So this is a PHP application. It has no framework whatsoever. It's a very ugly index.php file just to demonstrate how it works. So here in Composer.json, we see that we have workflow and event dispatcher, and that's all we really need. We don't have anything else. In here, I chose in this application to implement it using PHP configuration, because this way we can have all the constants in the workflow itself, and we don't forget to update them. I see here I forgot to actually use the constants here, but in general you would use them there. So what I chose to do is make a get workflow function, use the definition builder, add the places, which is all your states, and then your transitions. So here you see the transition name, which is up here, and then your froms, your tos, and the last one is interesting because you see that you can have several froms, but only one to. And then we use a marking store, which is defining where this should be marked. We say it's single state, and it should be marked on the property state. And we return the workflow. And my phone is playing music. Thank you, not now. So this is our order, and we see that it has states. The workflow component looks for getters and setters, so you're going to need a getter and a setter. And then here in the index function, you create your order, you get the workflow using the static function we created, you apply a transition. So the way you do that in a workflow, you call the function apply. And then we, in this case, choose to echo. And then you can also check if you can apply a transition at all. If you can't do that, it will return false. So can transition to delivered is order workflow can. And then we see the order here. In transition confirm delivery. And then we say if it can transition or not. So if we run this code, in a live demo, everything goes well. Here we see transition to open, can't transition to delivered, false, because we can't transition from open to delivered. Then we transition to confirmed, transition to assigned to picker, and then we check again, and indeed we can transition. So that is how you would typically use a workflow. But we see one little problem here with order, because anyone can set the state. How do we protect anyone from setting an illegal state in the order entity? Anyone can use their application, and yeah, they can do something bad, because not every developer knows exactly how a workflow works. So I have a little bit of a hacky solution for that. Everyone likes hacky solutions. So here in a set state, I want a little bit of protection from ourselves. Typically, no one else will see this, but while we develop, we get this error, and that really helps us. So what I do here is that I use the debug backtrace in PHP to check which class we're calling setState from. And I want it to be method marking store, which is the class in Symfony that calls setStates. If it's not that, throw an exception. And this really helps us, and it really makes our code more robust, and I don't have to explain to everyone, because our exception already says, no, you can't do this. Great. Now, of course, we want to do some more things, because if we just check if we can transition and that, it's not properly demoing the application. So we have a new order again. We want to update some items, so we create products, and these are just simple dummy objects for no reason. So we create products, banana with a price, and then we transition. And with the transition we apply, and we say transition to, and then we assign the customer, which is me in this case, and then we confirm the order, and we assign the picker, Fruity Batman, and he will pick up my order. Great. So that is how very simplistic it could work. Of course, this is not very ideal because we var dump after every case, and you have to check everywhere with this transition method, and you might want to do a logging when you transition an order. So this is where events come in. So if we check out version 3, 4, right. So how many here used events before? Okay, a few. How many know what events are about? Okay, so let's go back to the slides. Right. So before we continue with the demo, let's quickly look at events. So in Symfony and in most software projects where we have events, we have an event dispatcher. That's a central object. And we have listeners who want to listen to events, listener 1 and listener 2, and they connect to the event dispatcher. And then there comes events. And in the listeners, we have defined which events we are listening to. So when event 1 and event 2 comes, listener 1 has said, I listen to all event 1 listeners, and listener 2 has said, I listen to all event 2 listeners. So, to all event 2s. And so all of them goes to the event dispatcher first, and the dispatcher's job is to give it to all the listeners, and they do whatever it is they do. Exactly. They go there, and they do the code. So when we give someone an event, it's up to the listeners to continue, and we can just hook up listeners so that we never have to know from our original code what happens after. We only know that it happened, and that means single responsibility. It's source tight coupling, and that's great. It really helps you, and I would suggest you all look into event-driven systems more, because it's really useful. And it helps you have a plug-in system that is easy to change and easily adaptable. Now, Event Dispatcher is a component in Symfony that you can also use standalone. So you just require it in Composer, and then you write a listener. So here we have the order workflow listener, which implements Event Subscriber Interface. But instead of showing this, because we're short on time, I'll show you in the demo. Right. So with the event dispatcher, Symfony already has an event dispatcher here. So what we do is we say, okay, we want a new event dispatcher. And we want a new order workflow listener, which we created here, that implements the event subscriber interface. What the interface does is that it has one function, which is get subscribed events, and it returns key value. Which event do I listen to, and which function in this listener do I want to call? So the workflow component, it's on leave. It calls an event workflow, then whatever you named your workflow, and then leave. And then we want to go to on leave, and it executes that as soon as there's an event going on. Great. So we add the subscriber to the dispatcher, and we get a workflow like before. Now what we see here is that there's no more echoes and things in our code anymore, because in our workflow listener, every time we leave, it will do this. So it's easier if I simply show you. So, order ID 1, perform transition update item, etc., etc. So the workflow component will throw several events. You can think of it a little bit like a fort. So it will protect you from anything. There's the guard events, so that's the guards in the gate of the fort. And then if you want to enter the fort, there's an enter event right before you enter. There's guard that blocks you and throws you away. There's entered, which is right after you pass the guards. And there's leave when you're done. And then, of course, it's still not perfect to have all of this code in our index.php. So what we do in the last version is that we make an order service. And the order service then updates the pickers and does all these things, and then transitions. But in our transition function, what we did here is that we first check if it can transition with the workflow, and if it can't, we return the old order. So we see here in the construct, we give it to order, and that's set to order. And if we, for instance, update a picker, we have a changed order, we update the picker on the order, and then we transition with this changed order. And if we can't, it will return it. If we can, it will apply it. What you typically would want to do here as well is to add some debug logging and things like this. And eventually it sets this order to the order it should be. And then, finally, our index.php looks really clean. We don't have any logging or anything like this in our order service. We can add anything that happens when we transition. So when we wanted to recalculate all the prices, that was very easy to do because we added logic to the listeners. We did not have to change what happens because we already transition and we can just hook up something new. And that's the magic. I'm not going to show you this. So the workflow component does so much for us. And it solved all our challenges indirectly. It's keeping the orders and prices up to date, because every time we transition, we call on completed in the order workflow listener, and we update the totals every time, except for when it's delivered, because we really don't want to change something once it's delivered. So, making our consumers love us, we could hook up logging really easily by looking at by hooking it up to the event system. And we can handle cancellation of an order automatically because everything already knows what goes on at all moments, so we basically get that for free. Now, handling a large amount of push notifications is going to take a bit longer for me to explain, so I will do that quickly, and whoever is interested can discuss that with me during lunch. But very quickly, what we did is that every transition has a name. So we created our own order event service, and we tell it that an event happened, like this. And we tell which type it is, and that's the transition name. And then in the SMS notification handler, we have all the transitions that we can handle. And then what it does is that it has an RabbitMQ queue, and it queues up all the things, all the events. And if we see that there's a lot of events, we auto-scale the workers, so we have a lot of workers that handles and sends out these push notifications. That's very quick, simplified. So, conclusion. We already think in states and workflows. And state machines make business logic explicit. It shows us everything we need. And workflow component does so much for us already. It's really nice what it does. It forces us to write good decoupled code. Yeah, that's what it does. So any questions or contributions? This talk is for you.
Thank you for your speech.
Thanks for the talk. The bug backtrace is production ready. Do you use this technique in production, or you use another way to protect state in the order? Thanks.
So I could use it in production as well, yes.
So, questions from Slido. How it looks in a DDD way?
Sorry, in DDD?
How it looks in DDD way?
So in DDD, you make sure you define your model like you typically would, and there's nothing that changes if you use DDD or not. You define your order and all your models. I'm not sure how to explain it properly, sorry.
Okay, next. Is there ability to specify permissions who can transit per each transition, for instance by user's role?
Yes, so when you transition, you have the guard events. And when you have the guard events, you can say, okay, if the user has this role or that role, don't transition.
Is there a beautiful way to visualize states from state machine?
Sorry, can you repeat that?
Is there a beautiful way to visualize state from state machine?
I'm not sure. Is there?
There, this one.
Right. Is there a beautiful way to visualize states from state machine? Yes, I was going to show you this. It's Symfony has a command you can call, and then it gives you a nice output. So it gives you a graph of your state machine. It's really nice.
Implementation in a real product?
Yeah, so this simple demo that I showed you, that is not how it looks like in production. We don't have the debug backtrace in production, even though I say you could have. We have a lot of debugging code and things. So yeah, we use it in production for a very, 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 very large site, and it works great. But be a bit careful.
What is alternative for Symfony workflow? What is alternative for Symfony workflow?
The alternative is you write it yourself, or I haven't found another good workflow component so far, but it is something you can write yourself if you want to keep track of states. That's what we were going to do initially.
Workflow depends from the payment method. How could you handle it? Online, offline?
So the payments. It doesn't have to do with the workflow specifically, but we use Stripe for that. and we handle, one thing with handling money in PHP is never use floats. So always use BC math for money. And then you use the Stripe, or we use the Stripe API, and every time we transition, we recalculate everything using BC math. So we add up all the products and how many you have of each, and we recheck the price and all the promotions and everything you have.
Does workflow component break encapsulation? Maybe aggregate root has to manage states?
Sorry?
The first one.
So, does workflow component break encapsulation? Maybe, I'm not sure. I can't really answer this.
Could you please summarize what exactly the workflow component can do?
To summarize what the workflow component can do. So summarizing, it keeps track of your states, but you can do that yourself by having your state in your model. But it helps you by having this event system hooked in, and it helps you by this checking for states. And this is something you can write yourself, but it really helps you. And also you can dump your workflow, and you can debug your workflow easier with the workflow component.
Business logic in YAML file?
You don't have to. You can define what you want to use. So it's not really business logic, I would say it's configuration. And you can use PHP or YAML or XML for that.
How you would resolve exception? What would happen? Wait. Yeah. How you would resolve exceptions that would happen on some of workflow steps? For example, return to previous steps, and how workflow implement working with DB?
So this always depends on your application. So you saw, for instance, what we did in a demo application. We would check first if you can transition, and if you can't, we wouldn't change the order at all. So that's one way you can do it. And in a database, typically you can start a transition. So then you start a transition, you try to transition with the workflow. If that doesn't work, you roll back. That's one way to solve it.